In these problems, we are finding derivatives by simplifying a difference quotient. So a derivative is a measure of the slope at a single moment along the curve of a function, and or it's the expression that expresses how you find that slope. And the way we think about finding this is by thinking about a tangent to the curve. So if you wanted to find the slope at this point, you'd try to draw a tangent line to that curve. We don't really have a good way of doing that. I mean, you could eyeball it, but you're not going to be perfectly accurate. So mathematically, what we do is we think about placing another point on the line and then drawing the line between 2 points, because we know how to draw a line between 2 points. And the distance between those two on the x, we're going to call h. And then we're going to start moving that point closer and closer and closer to the original point, and find the limit as this distance h shrinks down to 0. If we can do that, if you can find that limit, you will have the derivative of that function. You'll have an expression for the slope at that point on the function. So let's start. We've got f of x is 3x cubed, and we're going to use this difference quotient. And this really is just the formula for the f of x plus h. That's this point right here, and minus f of x is this point right here. It's the y values for those points. So this is the difference in the y values, the rise, and h is the difference in the x values. It's how far apart those are. And so this is rise over run. So this is our formula for slope. Let's go ahead and plug our function in there and see how much algebra we're going to have to do here. So our function is 3x cubed, so the f of x plus h is 3 times x plus h cubed. And then we're going to minus 3x cubed. That's just our f of x. And that all goes over h. So to evaluate this, we're going to look at the limit as h approaches 0. So we need to get h off the bottom of the fraction. That's our chief goal here. So this is going to be a fair amount of work. I think what we need to do first is actually cube this thing. I'm gonna square x plus h first in my head. So that's x squared plus 2xh plus h squared. And now I'm going to multiply that by x plus h again. So first all the x's. So that's x cubed plus 2x squared h plus xh squared. And now the h's plus x squared h plus 2xh squared and plus h cubed. And then we've got some like terms here. We've got x squared h and x squared h, and then we've got xh squared and xh squared. Looks like it's going to be 3 of all of those. So I'm going to have x cubed plus 3x squared h plus 3xh squared plus h cubed. And all of that is just this little chunk. So we've got to multiply all of that by 3. Then we got to subtract 3x cubed and put it over h. Okay, I can see how this is going to work now. So when I put the 3 through here, let's do that. We're going to get 3x cubed plus 9x squared h plus 9xh squared plus h cubed minus 3x cubed, still all over h. But look, the 3x cubeds go away because you have a positive and a negative one. Everything else has an h in it. Boy, that's a funny looking h I drew down there. So we can cancel. So let's take that, 1h there, 1h there. This would become a 2. Let me rewrite that expression so it's a little clearer. We ended up with 9x squared plus 9xh plus h squared. And what we want now is the limit of this as h approaches 0. So think about what would happen to this as h gets closer and closer to 0. Well, this quantity would get closer and closer to 0. So would this. You're multiplying by something getting closer and closer to 0. So that's going to get closer and closer to 0. So all we're left with is 9x squared. So the derivative of 3x cubed is 9x squared. And if you wanted to know, say, the slope of that particular function at the point 1, you'd plug a 1 in for x. It'd be 9. that's your answer. You can know the slope of that function at any point along its length. Let's try one more. These are pretty long, but sometimes the algebra is what you need a little bit of brushing up on. So I'm going to try one with a radical sign in it and see how hairy this gets. So our function is 3 times the square root of x minus 5. So let me write out the difference for quotient here. So 3 times the square root of x plus h minus 5. So I'm putting in x plus h for x in the function. And then this is going to be minus just f of x, which is square root of, or 3 times the square root of x minus 5. And then all of that goes over h. What are we going to do here? I think because I've got radical signs and I've got a minus in between, I think what I'm going to try to do is actually multiply by the conjugate of the numerator. So we're going to multiply by 3x plus h minus 5 plus 3 times x square root of x minus 5. And we have to do that on the bottom too. So same thing. Okay. What that's going to get me on the top using the difference of squares is the first term squared minus the second term squared. So that would be 9 times x plus h minus 5 minus 9 times x minus 5. I think that's going to help us quite a bit. And on the bottom, we're going to have h times that whole thing we just multiplied it by, which is 3 times the square root of x plus h minus 5 plus 3 times the square root of x minus 5. This may not look any simpler, but I guarantee we're getting there. Let's look at the top now. I'm going to multiply the 9's through. So we've got 9x plus 9h minus 45, and then minus 9x, and minus 9 times a negative 5, so a plus 45. And let's see, we've got multiple things that can cancel here. So 9x and negative 9x, 45 and positive 45. We only end up with 9h on the top. That's really great because we've got h times 3 times the square root of x plus h minus 5 plus 3 times the square root of x minus 5 on the bottom, and these h's are going to cancel. Now, let's try to take the limit of this as h approaches 0. I think we can do that now because we're not multiplying by 0 on the bottom. If you think about where h is and it approaching 0, here is the only spot. So really, this bottom would become 3 times the square root of x minus 5 and 3 times the square root of x minus 5. So you've got 2 of those. You can put them together. Well, you've got 3 and 3. You've got 6 of those. So you can put them together. 6 times the square root of x minus 5 on the bottom. And it looks like we've got a 9 on the top, and we could probably simplify that. So yeah, simplify that. So dividing by 3, we've got 3 over 2 times the square root of x minus 5. And that should be our derivative. Whew. So a lot of hairy algebra in there, but that was how to find a derivative by simplifying a difference quotient.